area of trapezoids. A trapezoid is a shape where one pair of sides is opposite and parallel, and the other two sides are not parallel. The trapezoid has two bases, base 1 and base 2, and also has a height, which is the distance straight up and down between the bases. The formula for the area of a trapezoid: 1/2 times the height times the sum of base 1 plus base 2. So adding the two bases together, multiplying by the height, and then dividing by 2 will give you the area of a trapezoid. First question, and first trapezoid. Looking at the trapezoid, we have two bases, 7 inches along the bottom and 3 inches is the top base. The height again is 4 inches, goes straight up and down. To find the area of the trapezoid, we can first add the two bases together. In this case, 7 plus 3 would be 10. And we can multiply by the height, which would be 4. 10 times 4 would be 40. And the last part of the formula, 1/2, or you can also divide by 2. 40 divided by 2 would be 20. Looking back at the trapezoid, the length is inches. Multiplying the 10 inches times the 4 inches, inches times inches would be inches squared. So the area of the first trapezoid is 20 inches squared. And second question, last question for this section. This trapezoid is turned sideways. If you did rotate your paper, it would look like the other trapezoids that we solved. The bases, again, are the parallel sides, so they're opposite of each other. In this case, 18 and 6. Adding the two bases together, 18 plus 6 will be 24. And from the formula, after you add the two bases, we can multiply by the height. The distance between the bases, in this case, is 9. Multiplying 24 times 9. 4 times 9 would be 36, carrying the 3. 9 times 2 would be 18, plus 3 more would be 21. 216 is the bases added, multiplied by the height. The last part of the formula is 1/2, or divide by 2. 216 divided by 2. If you take half of 200, that would be 100, and half of 16 would be 8. So 216 divided by 2 would be 108. Looking back at the diagram, the distances are feet. We multiplied 24 feet times 9 feet, so the area 108 feet squared. Find the area of a trapezoid with bases 12 centimeters and 18 centimeters and height of 10 centimeters. If you want to draw a picture for this, you can first draw a trapezoid. The bases, 12 centimeters and 18 centimeters, you can place on either base. And the height of 10 centimeters, again, is the distance from one base to the other base, which would be 10 centimeters. Solving from here, the formula again, you can first add the two bases together. 12 plus 18 would be 30. And multiplying by the height, which is 10, would give us 300. And the last part for trapezoids, after you add the bases and multiply by the height, multiply by 1/2, which is the same as dividing by 2. 300 divided by 2 would be 150. The units again for the problem are centimeters. Multiplying centimeters times centimeters would be centimeters squared. So the area of the trapezoid, 150 centimeters squared. Title of the last section is called Pythagorean Theorem. The equation for Pythagorean Theorem is a squared plus b squared equals c squared. To use this formula, we can use it when we have a triangle with a right angle or 90-degree angle. The two letters A and B will be the two short sides of the triangle that are touching the right angle. And letter C is the longest side, also called the hypotenuse of the right triangle, that is across from the right angle. When you have a right triangle with a 90-degree angle, if you square A squared, and you square B, which is B squared, add those together, that will be equal to C squared. First problem, using Pythagorean Theorem. Given a triangle with two sides of 3 and 4, we can find the missing side, which is C. Pythagorean Theorem again, you take each of the two short sides, the two sides that are connected by the right angle, and we'll square each number. 3 squared would be 3 times 3, which would be 9. Adding to that, the other side squared, 4 times 4, which would be 16, and that's equal to the side that we're finding, in this case c to the second power, or c squared. Adding 9 plus 16 would be 25. And to solve for c, to get rid of the exponent 2, we can take the square root of both sides. The square root of 25 would be 5, and the square root and square would cancel. So we have the answer of c equals 5, or 5 equals c. There's no units given in the problem, so there's no units for the answer. Second question, and last question for the section. Again, we have a right triangle with a right angle. The two short sides are 5 and x, and the long side, called the hypotenuse, across from the right angle is 13. Using Pythagorean Theorem, you can take either of these short sides first, 5 for example, and square 5. 5 times 5 would be 25. Adding to that the second side, which again is touching the right angle, in this case is x. Squaring the x would be x squared. And that's equal to the longest side, the side across from the right angle, 13 squared, which would be 13 times 13, and that's 169. To solve for x, find the missing side. We want to get x by itself. We have to first get rid of the 25. Opposite of adding 25 would be subtracting 25 on both sides. And we'll have x squared equals, subtracting straight down, 9 minus 5 would be 4, 6 minus 2, and the 1 comes down. X squared equals 144. And again, to get rid of a square, we can do the square root. The square root and the exponent cancel. X equals the square root of 144, which would be 12. So the length x, one of the sides in the triangle, x equals 12.